So this is 2,2 alpha, and we're going to start with the definition, the density curve. So a density curve, the area underneath the curve, it doesn't matter what the shape is, the area of the curve is 1, all right? And then we describing a density curve, remember describe is the prompt, center, shape, and spread. So we're here. If the density curve is approximately normal, then we use the mean for the center and the standard deviation for the step. Step, spread, variability are all synonyms, okay? If the shape is skewed, we would use the median for the center and the IQR for the spread. All right, so we're going to specifically deal with one type of density curve, which is the standard normal curve, the normal distribution. So the normal distribution, and we put this in your calculator, I hope, last week, would look like this. We go to y equals, in this one I have it in y8. And if I push zoom 4 for this, it's not a very good picture. So we said, if you go to zoom, memory, we stored it. So we just recall it, a window that's appropriate for this standard normal curve. And then that stays in there until you type over it. So you have zoom, memory, store. The calculator allows you to store one window. And then if I go here, that's the window that was in there. And we, you know, -3 to 3 is going to capture, you're going to find out 99.7% of the area of the curve. So that's all we need to see from that, okay? So here's a graph link of the curve, which we just had on the calculator. Oh, I'm sorry. If we didn't put it in our calculators, let's do that. It's my fault. I put it in there for the other class. So in your calculator, go here. Go to y equals, and I just put this down here in y8, just to get it out of the way. You can have it anywhere down here lower. So in y8, you go to second vars 1. Second vars 1 will bring this up, normal PDF, and your prompts are x, 0, 1, meaning what? You want the input to be x, you want the center to be 0 and the step to be 1. And then you just turn this on and off. You're not really going to use it. It's just nice to have a picture of this to visualize it. And then for window, we're going to go x min -3, x max +3, and make the x scale 1. And for the y's, we went from -2/10 to +5/10. And this y scale being 1 isn't going to affect anything because we're not even going to see any of the notches on the y's. But then after you do that, if you have this window in there, right, -3 to 3 for the x's, -2/10 to 5/10, and you can change the y's if you want. You know, you want a better, you want a different perspective on it. You go to zoom across the memory and you push 2, store, and what that does is that stores that one window in there. So anytime you zoom memory recall it, it'll type that window. So if I went here, you're not going to do this. I push zoom 4, that's not a good window for that picture. So without having to type -3 to 3 again, I just go to zoom, memory, recall, and we get the picture back, okay? So here is a version of that picture. And what I did was, I marked this up. You see this vertical line? And if you had calculus, this makes sense to you. It's a connection. And if you did not have calculus, it's not a big deal. I mean, we don't need the calculus to do this. That here, if I go from the left, this curve is opening up. And you get to this vertical line, it begins to open down. The concavity changes. And it's opening down till you get to this vertical line, and it begins to open up again. So whatever the magnitude is that takes me to this, below this inflection point, that's the magnitude of the step, of the standard deviation. So I just copy that and paste it to the right and to the left. So this notch right here is for 2 standard deviations, meaning this is the same distance as this is. There's no inflection point above this. That's only used for the first standard deviation. Okay? And you look at these symbols down here. These are Greek letters. What's going on? Well, this is a new vocabulary word for you. Ready? Parameter. Right? It's alliteration. Parameter refers to the population. It's what we're trying to identify. If you know what the population is, for example, we told you about those AP scores because they publish the results for all the children that took the test. So that's they're parameters. The population parameter, the center is mu, and the spread is sigma. So this mu, well, you told us the center was x bar up here. The center, the mean is x bar. That's a Roman letter. That's the center of a sample distribution. So the sample, again, it's also alliterative, gives you a statistic. So you have to remember, parameter goes with population, a statistic goes with sample, but you have that alliteration there to help you. And we recognize that with Roman letters. So if you see Roman letters, X, S of X, that's telling you you're dealing with a sample. If you see Greek letters, that's telling you you're dealing with all of the values. That's the population. So right here, this is just a picture of saying, till I go out to the inflection point, that's 1 step to the right. That's 1 standard deviation to the right, 1 standard deviation to the left. And then this whole picture captures 3 steps each way, because even though this, the curve is asymptotic to the x-axis, there's so little of the curve that is not on our screen that we don't concern ourselves with it, okay? So we're gonna do 2 problems. I'm gonna pause the video, and you're gonna do 2 problems, 43 and 47. Then we're gonna come back and go over those, and then we'll do 45 together, okay? And then before we go, I'll just give you a recommendation about Wednesday.